This video is part of a series of 6, that's one for each topic, that's intended to take the guesswork out of answering multiple choice questions. If your knowledge of physics can't lead you to the correct answer, you might find that it can at least let you narrow down your choices. Here's the first question from the waves topic then. The diagram represents a wave travelling from x to y. The wave travels from x to y in a time of 0.5 seconds. Which row in the table shows the amplitude, wavelength and frequency of this wave? So we'll start with amplitude, which, looking at the diagram, can be measured from the central line to the crest. That's the highest point in the wave. Or from the central line to the trough, the lowest point in the wave. Either way, the amplitude here will be 2.6 divided by 2, which is 1.3 metres. So we can rule out options B and D already. Next up, to calculate wavelength, we need to count the number of waves in the diagram. That's 1, 2, 3, 4. If the length of 4 waves is 12 metres, then the wavelength must be 12 divided by 4, which is 3 metres. Now we can rule out option A. To calculate frequency, we use the equation F is n over t, number of waves divided by the time taken to produce them. If we observed point X, we'd see all 4 waves passing in a time of 0.5 seconds. So substituting those values into the equation gives a frequency of 8 Hz. So our answer is C. Here's the next question. A student makes the following statements about different types of electromagnetic waves. 1. Light waves are transverse waves. 2. Radio waves travel at 340 meters per second through air. 3. Ultraviolet waves have a longer wavelength than infrared waves. Which of these statements is or are correct? So first off, light, along with all other electromagnetic waves, is a transverse wave, so point 1 is correct. Sound, on the other hand, is a longitudinal wave. Second of all, radio waves don't travel at 340 meters per second. That's the speed of sound in air. Radio waves, like all other electromagnetic waves, travel at 3 times 10 to the power of 8 meters per second. What about the last point? Well, here's a diagram of the electromagnetic spectrum with the radio waves, which have the largest wavelength and lowest frequency on the left, and gamma rays, which have the shortest wavelength and highest frequency on the right. Looking at the diagram, it's clear that infrared waves actually have a longer wavelength than ultraviolet waves. So the last point is incorrect, meaning our answer is A. Make sure that you have a method of memorising the electromagnetic spectrum so that you can answer questions like this one, as well as one that will come up later. One method is to remember this phrase: raging Martians invade Venus using X-ray guns, although other phrases are available. Next question. A ray of red light passes through a glass block as shown. Which row in the table shows the angle of incidence and the corresponding angle of refraction at point X? And here's the table, which we'll move over beside the diagram. So this ray here is what we call the incident ray. The light comes out of the ray box and then strikes, or is incident on, the flat surface of the glass block, what we call the glass-air boundary. The angles in reflection or refraction questions are always measured between the ray of light and this dotted line known as the normal, which is 90 degrees to the surface. That means that this is the angle of incidence, not the angle marked as 55 degrees. Since the angle between the flat surface and the normal is 90 degrees, the angle of incidence must be 90 minus 55, which is 35 degrees. Already we can rule out 3 of the answers, B, D and E. This is the refracted ray. And again, to measure the angle of refraction, we have to find the angle between it and the normal line. So that means this angle here. Its value will be 90 minus 30, which is 60 degrees. That means that the answer is A. And now it's time for another picture round. Which of the following diagrams shows the diffraction of water waves as they pass between 2 walls? Bring on the first contender. So what we're looking for here is for the waves to have the same wavelength after passing through the gap between the walls as they do beforehand. The wavelength is just the distance from one wave crest to the next. Also, the waves should be spreading out as they pass through the gap. In this diagram, the wavelength isn't changing, which is good, but the waves aren't spreading out, which is bad. It's a no from me. Next up, the waves appear to be bending here after they pass through the gap, but again, they're still not spreading out. Answer B gets the thumbs down too. What about C? At last, we've got waves spreading out as they pass through the gap, but this answer still isn't the right one, since the wavelength before and after the gap isn't the same. Onwards to the next answer. Wavelength the same before and after the gap? Tick. Waves spreading out as they pass through the gap? Tick. This one looks good to me, so it must be the answer. I imagine there must be something wrong with answer E. Let's take a look. This one has the same problem as answer C. The wavelength before the gap should be equal to the wavelength after the gap, and that's not the case here. Looks like the correct answer was D. Now it's time for another diffraction question, but you'll also need to remember your electromagnetic spectrum from before. A student makes the following statements about diffraction. Diffraction occurs when waves pass from one medium into another. 2. Waves with a longer wavelength diffract more than waves with a shorter wavelength. And 3. Microwaves diffract more than radio waves. Which of these statements is or are correct? First of all, it looks like that first statement is actually describing refraction rather than diffraction, so it's not correct. You'll know that if you've watched my video on waves definitions. Mind you, you'll maybe know that if you haven't watched my video, but it's still worth a look. You might also know that statement 2 is correct. Waves with a longer wavelength diffract more than waves with a shorter wavelength. See, physics isn't all about using equations. There are some facts that you'll also need to remember. So don't forget those 6 definitions videos. Now that we know statement 2 is correct, we can use it to check whether statement 3 is correct or not. But we will need our trusty electromagnetic spectrum diagram. We can see that radio waves have a longer wavelength than microwaves, and we know that longer wavelengths diffract most, so the last statement must be false. All this means that our final answer is B. In case you still wanted to know the correct definition for diffraction to correct statement 1, it is the bending of waves at a gap or obstacle. So if this video has helped you to get over some obstacles and fill in some gaps in your physics knowledge, then why not drop a like all over it? And drop a subscribe on my channel too. Till next time, keep physicsing.